Okay, let's consider the equation h of ty equals t cosine y plus 1 over y, rather the function h of ty. We're going to consider the equation h of ty prime equals 0. We'll see why we want to do this, but let's get the mechanics of this thing out of the way first. Okay, so h of ty prime is the derivative of this, so that's going to be t cosine y plus 1 over y prime equal to 0. Now taking the derivative of t cosine y, we have t prime cosine y plus t times the cosine of y prime, and then that's plus the derivative of 1 over y prime. T prime is just 1, so this gives us cosine y. Cosine y prime. Now the prime indicates derivative with respect to t, so y itself is a function of t, so for taking the derivative with respect to t, we have to have the derivative of the inner function, y, out in front here, times negative sine of y. Now you might need to sort that out. Review implicit differentiation if necessary. This is not a case of implicit differentiation, but you have the same principle in differentiating this function y, which is a function of t. And over here, this is the reciprocal of the y function, so this is going to be y prime times negative 1 over y squared. And that's what's going to equal 0. If we simplify this, we get t minus 1 over y squared times y prime, and that's just plain wrong. I left out the sign of t, so let's put a domino down here and try to cover up most of that. Yeah, that'll be good. A domino and a dollar. And now the mistake disappeared and it never happened. Okay. Again, if we factor out the y prime, we're going to get negative t sine y minus 1 over y squared times y prime plus cosine of y equals 0. Now it should be pretty obvious that this thing having like a 1 over y squared and a sine of y is no linear equation. It's not linear at all. So we're in uncharted territory here. Let's look at where this leads us. Okay, now y prime is dy dt, so we have this times dy dt plus cosine of y equals 0, where what's in here repeats what we have up here, and we're going to write it out here in a minute. Multiply both sides by dt. Now you can't really multiply by dt because it's not an algebraic quantity, but you can treat it that way. Now again, you see theoretically why we can do that, but that gives us negative t sine y minus 1 over y squared dy plus cosine of y dt equals 0. Now, you're probably wondering why in the world we'd want to do this and what in the world this is good for, and we'll see that in a minute.